So recall the Pythagorean theorem. Today we're talking about the Pythagorean theorem and its converse. And so the Pythagorean theorem says if you have a right triangle, then, everyone, a squared equals c squared, okay? C is the hypotenuse, the longest side, the side opposite the right angle, right? The other legs are A and B. The other sides are called legs. They're A and B. It doesn't matter which you label A or B. But C is very specific. It must be the longest side, the hypotenuse, the side opposite the right angle. We're going to use the Pythagorean theorem, and you're going to see that the algebra we've learned will be useful for finding unknown sides. But starting off, here's just a basic problem, like 7th grade level problem. Can you find B? So please begin with what? Who can tell us what we need to start with? What do we always start with? The formula, right? So we would begin with writing it down each time, so it's really solid in our minds. And then we substitute the known values. They labeled them, so we have no choices here. We just substitute. 4 squared is, and what is 9 squared? Okay, so it's just one of those basic problems, right? So the next step, Anderson? And what do you get?
65.
B squared equals 65. And then to find B, we would take the square root. And so B, now, does 65 have any perfect square factors in it? No. So you could leave it in simplest radical form, which is the square root of 65. If you were asked to approximate the value to the tenths or something, then you would go ahead and use your estimate, right? And your estimate would be 8.1. Good. Okay, but it gets more interesting when we have sides that are more interesting than this. Like this. Find the unknown lengths of a right triangle that has one leg that is 1 foot longer than the other leg. The hypotenuse is square root of 13 feet. When you receive this type of question, you usually don't even have an image of a triangle. So, of course, a great strategy is to draw a right triangle, just put one down, and try to identify expressions for the legs. We know the hypotenuse, so we just can write that in. But how can we express these legs? I mean, we have A and B, I guess, right? But how are they related to each other? We could say, if I have leg A, we could say leg A is just leg A, right? But what does leg B equal if it is 1 foot longer than the other leg? Let's say that it's leg B that is 1 foot longer than the other leg. What would we say, John? Good job. So B would be A plus 1. So we're going to use the expression A plus 1 for the entire length of B. We like to have one kind of variable in our equations, right? So the Pythagorean theorem says this, A squared plus B squared equals C squared, but what will we substitute into this?
A plus 1.
Right, we have A squared, but B, we don't want to call it B, we want to call it A plus 1 squared. Good. Equals the square root of 13 is being squared. And now we have to be careful. I mean, the square root of 13 squared is just 13. And A squared is A squared. But what is A plus 1? What is it not? A plus 1 squared is not, Cassandra, what is it not? It is not A squared plus 1 squared. Then that huge mistake people make. It is not A squared plus 1. So if you need to foil it, distribute it out, write A plus 1 times a plus 1, and go ahead and distribute. A squared plus 1a plus another a. So how many a's do we have? 2 a's, and then plus 1. Or we learned that pattern, the perfect square trinomial, where we took the square of a, the square of the last term, put them in their places, and then in between 2 times ab, right? 2 times a plus 1. 2a in this case. Okay, so now good, we got that done. And we say, how many a squareds do we have? 2. So we say 2a squared plus 2a plus 1 equals 13. So what must we do?
Subtract 1.
Good, so set it equal to 0.
Just kidding.
Now, I mean, you could subtract 1, but that's not going to set it equal to 0, so we probably want to subtract 13, right? And 2a squared plus 2a plus what? Or shall I write it as minus 12? What could make this more simple right now?
Take out 2.
Good, divide by 2. Divide both sides by 2. So we have a squared plus a minus 6. A quadratic equation. Is it factorable? Okay, Johnny, tell us the factors. Good job. Plus 3 minus 2. Good. And so what are our values for a then? And 2. Those are the solutions, right? Now we have to go say, could a equal negative 3? Could a equal negative 3?
No.
Could I have this triangle side being a negative length? No. So we throw that one out. A must equal 2. So to answer the question here, how long are the sides? We have a equals 2 and b equals what?
3.
Plug your 2 in and you have 3. So there are your answers. Okay? So you can see how geometry requires knowledge of algebra when you start finding sides that are binomials. This is not something you did in 7th grade. You simply did things like this in 7th grade, okay? In pre-algebra. So let's try this. I'm going to go ahead and pause the video and come back and check your work. Okay, so we drew the triangle. We have the expression a plus 3 for the side that is 3 inches longer. We carefully squared that binomial, getting a perfect square trinomial. Simplified, and we're at the point of finding these solutions of 9 and negative 12. And everyone is saying negative 12 is extraneous. Doesn't work in here. We can't have a side negative 12. So the legs are 9, or when we plug 9 in here, we have 12. Okay, legs of 9 and 12. Okay. The next question, which you don't need to write in your book, but let's just look at, is you have a swimming pool that is a rectangular shape. It's 30 feet by 60 feet. And you swim across it from corner to corner. So what are you swimming on this triangle? The hypotenuse. You're swimming on C, right? And so let's quickly see if we can find how far you swam. So we would use, again, a squared plus b squared equals c squared. And that's because if it's rectangular, we know these are right angles. Okay? So we plug in these values, and we're looking for the hypotenuse. 30 squared is? It's just 3 squared and then 10 squared, right? So that's how you do that. 60 squared is? 3,600, good. And when you add 900 and 3,600, you get? Say it. Good, 4,500. What will we do to both sides? So C equals, now if you weren't using a calculator, what perfect squares are in 45? So we have 9 times 5, and then what is this? It's 100, isn't it? Okay, what's the square root of 100? And the square root of 9. So we really have 30 times the square root of 5. If we were going to estimate, what would your estimate be for square root of 5? 2.2? 2.2 or something? So 30 times 2.2 is like 66? 66 feet. Does that seem reasonable?
Yes.
66 feet here. Does that seem reasonable? See? Okay, you don't even need to use a calculator. Right? Okay, the converse of the Pythagorean theorem. The Pythagorean theorem says, it's a conditional statement. It says, the hypothesis, if I have a right triangle, then the conclusion, a squared plus b squared equals c squared. If I have a right triangle, then a squared plus b squared equals c squared. The converse says, take the conclusion of that conditional statement and put it in the place of the hypothesis. Switch those two things, the conclusion and the hypothesis. So we would say, if a squared plus b squared equals c squared, then what can I say?
C squared minus b squared.
Now wait a minute. The original Pythagorean theorem says, if I have a right triangle, then a squared plus b squared equals c squared. So if I switch that, then if a squared plus b squared equals c squared, then I have what?
Right triangle.
A right triangle. This is a way to prove you have a right triangle, see? The Pythagorean theorem and its converse are both true statements. That's not always true with conditional statements, but it is true with this. We use the Pythagorean theorem more often than the converse, but if you wanted to prove something was right, a right triangle, you're trying to prove some kind of a right angle, you can use this converse of the Pythagorean theorem. Okay? So the questions down here are asking, do we have right triangles? If 3 legs of a triangle are these dimensions, does it make it a right triangle? What about this one? So we're going to use the Pythagorean theorem to test. And you did this before in pre-algebra, right? There's one leg that is really specific. It must go into one of these letters, right? Right, the longest leg must be what letter? C. Why is that? It's the hypotenuse. So when you're testing this, I like to put a question mark over my equal sign. Make sure you start there. Plug in the longest leg for C. The other 2 don't matter. It doesn't matter where you put it. So 7 squared is? And what is 23 squared? Anybody have it? Did anybody get 529? Okay. And have you tried 24 squared? Did you do it with on paper, scratch paper?
I got 576.
What are you doing under there? Are you using, is this true? And when we add 9 plus 9, we're going to get an 8 on the end, so this must not be true. So, no, this is not right triangle. So this one probably is, right? Oscar, how would you set this one up?
13 goes to c squared, then 5 squared plus 12 squared.
Now these numbers we should know. 5 squared is, and 12 squared, and 13 squared.
169.
We're still testing. And when we add this, 9, 6, 1, yes. This is a right triangle. Just by testing it in the theorem. Okay? Don't forget, you also have to do your review packet through page 108 by Friday, not by tomorrow, by Friday.